You're recording.
Okay, so welcome to the Intro to ANSYS workshop. So the purpose is just to basically get a quick familiarization with ANSYS, since ANSYS itself is like a really like industrial level, like simulation software. So I'm not going to be able to touch every basis on it right in this hour-long workshop. So it's just going to be like a quick and dirty kind of intro to ANSYS. Definitely in the future, I'm going to have some more in detail, like more workshops. But for this, it's just to kind of familiarize yourself with the process of starting a basic stress simulation on ANSYS. Specifically, we're going to be using ANSYS Workbench, which is the main, I guess, ANSYS product that us mechanical engineers are most likely going to use either in our projects here in school or in the future out in the industry whenever whatever jobs we end up getting. Most likely, if you have some sort of job that requires some sort of simulation, you're going to be using ANSYS Workbench. So quick rundown on what we're going to do today. First, using the CAD software of your choice, we're going to CAD up a quick geometry and then import it to the ANSYS Workbench environment, and then set up a quick stress analysis, and then analyze the results of the simulation. So I don't know, what are you guys are going to be using? You guys are using SolidWorks or NX, or what do you guys have on hand?
I've got SolidWorks right now.
Okay, that should be fine. I'm going to be using NX, but the basic like sketch, extrude stuff should be the same. So let me just, you guys can open up your SolidWorks. Okay, so first of all, I'm gonna ask, like, what do you guys want to kind of model? Like, do you guys have something in mind you guys want to kind of analyze? Don't make it too complicated, I guess, too, because it might take a while. But just some basic thing you guys want to.
Let's do like a ball.
A ball? You said like a basketball or something?
Yeah, I mean, nothing too complicated, right?
I never actually done analysis on like a
Spherical
something.
Oh yeah,
sphere.
What about like an I-beam?
Sure, we could do a quick I-beam, I guess. So first thing we're gonna do is sketch out the cross section of the I-beam and then extrude it so that we can get the I-beam. So I want to start my sketch real quick. Just a note, my units are in inches. So whenever I call out units, just reference it's in inches. So I'm gonna make this 2 inches. I make it like half an inch, which is essentially the thickness. Yeah. Never mind, let's change that. An eighth of an inch. to 1.5. Eighth of an inch. And I'm just going to mirror this top portion to the bottom. So this is going to be a reference line. And then I'm just going to get rid of a bunch of unnecessary lines. Extrude it. How long do you guys want to make it?
And just like a foot.
Are you guys in the same general step of where I'm at right now? Because right now we're basically good with this geometry, and I'm getting ready to export it so that I can import it to ANSYS. Are you guys good?
Yes, I'm good.
Okay. So I'm gonna just a quick note. Whenever you install ANSYS and you already have a 3D CAD software, most likely, I mean SolidWorks and NX, they already have like a built-in like tab once you install ANSYS to like make the importing process of the geometry quicker. I'm not gonna do that right now, just so that you guys get familiar with like the manual importing of the geometry. But like in the future, you just go to ANSYS and you would just click on Workbench and it would automatically port it to ANSYS Workbench. For now, I'm just gonna go to File. Just to be safe, I'm just gonna export it as a step file. And I already have the file location where I want it. Click OK. Should have already exported it. So have any of you guys ever opened ANSYS before?
No.
Okay, so I already have it open, but I'm gonna close it just so I can let you guys know how to open it, because it's kind of if it's your first time, kind of well, for me at least, it was kind of difficult to locate it. So you go to your start menu, you go to ANSYS, whatever version you download it, you should see a file under the start menu. You go down and there's a bunch of stuff that ANSYS comes with. And what you're looking for is Workbench 2019 R2 or whichever particular one you downloaded. So Workbench.
The ANSYS get linked with like a SolidWorks or like any 3D modeling
Yes, I know.
program?
When I used to use SolidWorks, it would have a tab just like it's showing here in NX to like make the porting of the geometry easier. So you can configure it. Just have to play around with the settings. So this is the ANSYS Workbench interface when you first open it up. Here on the side is a bunch of like, I guess, different modules you can use to simulate different kinds of mechanical systems. Just a quick overview of this. If you already have like a turbo machinery, like a turbine or something that you already have modeled up, instead of doing everything manual, like analyzing and simulating everything manually, like ANSYS already has like a module that would kind of help simplify the process. Same thing with like a bunch of hydrodynamic stuff, fluid flow. Which my next workshop is going to be on ANSYS Fluent, which is basically a way to simulate like fluids. It's basically ANSYS version of computational fluid dynamics. So that could come really in handy with the drone team, where they could kind of simulate like how much thrust force their particular propeller they end up using, how much it would generate, and based on that, they could build like a mathematical model off of that and have an accurate simulation model to play around with. You would do all that sort of fluid simulation in fluid flow under ANSYS Fluent. But anything dealing with like statics and like mechanical solid kind of stuff, you use ANSYS Workbench, right? And then the module that we're going to use is called static structural. So you just click and hold, and then just drag it, and then just let go. And then this little like step process is gonna show up. One more thing on units, I like to use US engineering units. So make sure whenever you guys start, go to whatever units you guys are comfortable with. In this case, I'm going to be using US engineering. You guys all good? You guys are all where I'm at right now? I know some people joined late. Okay, so first thing we're going to do is go to step number 2, engineering data. Click on it or double click on it. You're going to be brought up to this. This is basically the materials you want to use for your simulation, like what kind of material your particular models is going to be made of. For this item in particular, we're just going to use structural steel. You want to see like the material properties of it, you just click on it, and then here on the bottom it's going to like show the basic material properties of structural steel. So it's going to tell you you click on it on the curve. It's going to tell you like the cycles. If you guys are taking an engineering material class, you guys will be familiar with what these kind of charts are telling you. So tensile yield test, it tells you right here. It says change it to the side. The yield strength of this particular structural steel, which I'm guessing is around the lines of 836 steel. It's 36 KSI, and it gives you like the basic. Gives you like the basic engineering data that you required. If you have like some sort of special alloy that you want to add, you just click on the engineering data sources. Another thing, when you click on the engineering data sources, it just gives you like a like a brief library of what ANSYS has pre-built. But if you go online, or for example, SpaceX has their own like unique library of alloys that they use. So like if I was to be using a SpaceX computer, they would have a bunch of their exotic alloys that they use for their structures and stuff. But this is a personal version of ANSYS. It just has like the basic stuff, like general materials. You click on it, it just has like polyethylene, structural steel, aluminum, air. If you go online and look up like ANSYS materials libraries, you could download them and import them. That way you have a larger library. But as it is, how it comes with when you first install it, it just has basic materials. If you wanted to add aluminum alloy, you just click on this plus, just for demonstration purposes. I just click plus, and then once you're done selecting your materials, you just click on as you can see, like the two. You just click on engineering data sources again, and you would see like the two materials that you have selected. Once you're done with the materials you want to use, you just exit out of engineering data. And just a rule of thumb, whenever you see like a check mark next to one of these tabs, that means like this particular step checks out. There's no particular errors. The next thing we're going to do is import our geometry on step 3. Basically the I-beam that we catted up. So you just right click, import geometry, and then in my particular case, I'm just going to browse it on my computer. I'm going to click on the part. This is what I named it. I don't know what you guys named it, but just select the part that you named and open. And you can see that it's going to check out. But in this particular case, I'm going to right click it and then try to open it in ANSYS' own little like 3D modeling application that it comes with. It's called Space Claim. So like I said, I just right clicked it and then I'm going to open it up. Might take like 30 seconds to load up. You guys have any questions so far?
No, man.
So this is like ANSYS like own little like cheap like 3D CAD like module that it comes with. It's just good to use to kind of check out whatever geometry you imported, just to check it out if everything like it checks out and stuff. So this is the I-beam that we imported. It looks pretty good to me. No like, there's no errors or nothing like that. If you ever want to modify it in here, you just do like the basic commands, like you can sketch on it and kind of modify it within ANSYS. But for me, it's good, so I'm just gonna exit out of it. So geometry checks out. This is probably the important step right here. This is where you set up your mesh, you set up your forces and stuff, your fixed constraints. So make sure you pay attention on this. So edit. Again, it's probably gonna take like 30 seconds to load up. Probably gonna get this kind of like tip or whatever you want to call it, kind of show you around. So on the left here, you're gonna see bunch of like, you can see the geometry. You click on it, you could expand it, and it's gonna show you like the actual 3D geometry imported. If you click on it, it's gonna highlight it in green. If you were to have a more complex part, it would obviously be the list would probably be bigger, and then each individual component would have its own individual like subpart and stuff. The next thing after that, you have materials. I'm gonna expand it. And as you remember, we selected two materials: aluminum alloy and structural steel. For this particular case, we're gonna make this structural steel, this I-beam. So under materials, you can just right click. So you're gonna select the material, you're gonna right click it and then create material assignment. And then you're just gonna, in this case, I want the whole part to be structural steel. So I'm just gonna right click on it and then select all. And then right here on the bottom, whenever you're doing an operation, here on the bottom left, it's gonna be like all your options you're gonna wanna do. In this particular case, since we're just assigning a material, the first thing is gonna ask you under general, it's gonna be scope and method, and that's basically like how you wanna select an object. If you select on the drop-down menu, another thing you can do is you can name particular parts of your geometry. If this was a more complex geometry, let's say you had a bunch of bolts of the same size, you could actually group them into a selection. Let's say you have 24 bolts in an engine of the same size and material, and you would just group them into a selection, and you would name that selection 3/8 bolts, 24 thread, or something like that. And then to select them and to add material, instead of selecting every individual one, you would just call out that selection. And this is what it's basically telling you right here. If you have a particular selection of, for this example, bolts, you just select them and it's going to automatically select all 24 of them, and you could apply that material to all 24 of them. But in this case, I'm just going to do a geometry selection. Since I already have it all selected in green, I'm going to hit apply. So click on it and apply. Once it turns red, it means that structural steel was assigned to this geometry. And then if you just keep reading further down, it just tells you like you selected it as structural steel, nonlinear effects, yes. Thermal strain effects, yes, even though we're not going to actually apply any thermal stress on it in this particular simulation. But if it was the case, then thermal strain will be taken into effect. And then down here, it just gives you the basic material properties of structural steel. So as you can see on the drop-down menu here, you can see that the materials, everything already checked out. Your assignment of structural steel to geometry checked out. So you just work yourself down. The next thing, coordinate systems, you can kind of just leave it as is. But the next thing you have to work on is your mesh, which is another important thing. So just click on it. And then up here in the ribbon menu, you just go under mesh. And what I usually do is I just initially I let ANSYS automatically generate a mesh. Usually it does a good job, but depending on the geometry, if it has like a bunch of weird curves and stuff, it's gonna mess up. Like it's not gonna be a good mesh. And the reason why you want a good mesh is because depending on the quality of the mesh, if you have like a low resolution mesh, you're not gonna get good results. But another thing you wanna take into consideration is like the computer you're using. If you have like not a good or not a powerful computer, then you basically limit it to a low resolution mesh, because the mesh is, the more resolution the mesh has, the more computing time your computer's gonna take. And if your computer can't handle it, if you use too much mesh resolution, it's gonna like crash on you midway through solving like the strengths and stuff. So that's just something to keep in mind. So like I said, I'm just gonna let ANSYS like figure out the mesh real quick, and if it checks out and I like it, then I'm just gonna leave it as is. If not, then I'm probably gonna have to add some more modifications to the mesh. But to generate a mesh real quick, you just click on this generate button here under the mesh option here in the ribbon. So just click generate. It's actually pretty good, like pretty uniform. Obviously here on the cross section, it's not that good, but I think that checks out for what we want to do. I would probably just increase the resolution a little bit more so that the rectangles are a little bit smaller. So here on the bottom left, or I'm just gonna go under, under sizing, and then remember I went under sizing, scoping method. I'm gonna be using selection, geometry. I'm gonna select the entire high beam, apply, and then type element size. And then here you define how small you want your elements, or in this case, what they mean by elements is like the little rectangles that it was broken up to. So in this case, it's like about 5/8 of an inch. I'm gonna make this a quarter range. So 0.25 inches. Hit enter. And then to refresh any sort of operation that you do under the mesh, you would just click on update here. So just update. It's gonna do some number crunching, and then as you can see, it upped the resolution of the mesh. Everybody's good so far? Are you guys following along?
Yeah, man.
Yeah, I'm good so far.
Okay, so for this particular geometry, the mesh checks out. But like I said, if it's anything more complex and you ever want to fix it, you need to do several things. Like sometimes if you have anything that's like rounded off, like a fillet or something, or some geometry that has some sort of like a radius, instead of the mesh like making these like uniform like square rectangle mesh shapes, it's gonna do some sort of triangles or polygons. If that's good if you're doing like rounded objects, but sometimes that's gonna give you some inaccurate results. So to kind of fix that, if you ever run into that problem, you would just go under methods, and then again you would select the geometry, and then under definition, its default state is automatic, but see selection, apply. But tetrahedrons, you could change the different types of mesh shapes that you can do. So just a quick rundown, tetrahedrons is basically the polygons like it's gonna do like triangles or pentagons and stuff like that, but it's not gonna do like squares. Hex dominant is basically what it did right here, which it does squares and rectangles. I've never done sweep. I've only really messed around with tetrahedron and hex. But if you ever want to fix anything, let's say, just like I said, it just makes a bunch of triangles and you don't want that, you just go under method, select your geometry, and then switch it back to hex dominant. So right now, You see that little yellow lining? It means you have to update it. So I'm just going to update it real quick. And then the green check mark already checked out. That means it's good to go. So the next thing we're going to do is we're going to add the fixed constraints and the forces to our geometry, which is under static structural. So two ways you could add this. You could right click and then go under this menu, or you could use the ribbon up here, which already has everything that was under that menu when we right click. You just click on it and then automatically this menu pops up. First thing I'm going to do is I'm going to add the fixed constraint. So what do you guys want to do? A cantilever beam or fixed on two ends?
Let's do the 3-point test, man.
The what?
The 3-point test, like fixed on both ends.
Okay. So fixed, click on fixed. Select the geometry you wanna add the fix. Then click on cross section, highlight in green, apply. That's good for that end. Add another fix. Select the other cross section. Hit apply. Now you're going to see under structures, static structure. You're going to see the two fixed points that we added.
I have a question.
What's up, man?
Okay, so you have two of those like fixed support, I guess, what would you call them? Like configurations? You can't just use one for both faces?
You can, but I've always done it this way, but maybe you could do it like what you said.
Okay.
But you can give it a try and see what kind of results it gives you.
Okay.
So now we can add our force or our load. So force, what do you guys want it, like in the middle or something, or it doesn't really matter?
Yeah, the middle.
See what I do. What do you guys want the magnitude of the force to be? It's in foot-pounds. Let's make it.
Let's do like a ton.
A ton, so 2,000. And then if you click on direction, obviously we want to go up, so I'm just gonna click on this red and black arrow, reverse it. Fine. And pretty good on setting it up real quick. So when I click on solutions, maybe that's going to give us some errors or something. But so under the solutions, we're going to want to take a look at deformation. So we're going to click on deformation and then total. Stress. Make sure you click on the bond miss, because the bond miss is what we want to use for like ductile metal materials. It gives us more accurate stress analysis as compared to other methods. I think here they don't really have other methods you could import or make your own methods if you like write your code or whatever. But as it comes with preloaded, if you're doing any sort of simulation dealing with any sort of metals that are considered ductile, you want to use bond miss. So the two that we select, deformation total and then stress, mon miss, UNT, is going to show down here under the solutions, and it has that yellow lightning, meaning that we need to solve it. So we can click on solve now. And then depending on your computer, it might take a while or not, or depending on how complex the simulation is. In this case, it checked out pretty quick. Let's check out if, let's check out what it came out with. So our I-beam obviously is 1/8 of an inch thick, so it's pretty beefy for an I-beam. It's 1 foot long. So as you can see, it really didn't even, I think the yield strength for this material for structural steel that we chose was like 36, 37 KSI. The max probably here on the edges, and that was like 11K KSI, which is pretty good. Obviously, this is exaggerated the way it bended. It's trying to show you like the direction it would deform, but in real life, it probably didn't even deform as much.
So I know on like SolidWorks, you can say like it'll show how much like it's exaggerated. Does it say that somewhere here?
Um, I don't really know how to what's it called, how to find that, I guess. But under the deformation, like the max that it deformed was like 2 thou basically of an inch.
Yeah.
So yeah, that's basically ANSYS static structural in a nutshell. It's pretty basic. I would say it's really easy. It's like SolidWorks, I guess, but you got way more options if you want to get more advanced. But if you want to do some basic stuff like this, it's pretty straightforward too.
And so like, let's say for, I guess the NASA rover project, like how would you incorporate this into like a report? Like, would you have to do it for each, I guess, like member of the like welded pieces, or are you able to do it in sections?
Yeah, ideally, what you like, if you want to work efficiently, you would do it in sections, and you would like whenever you model something, you want to make it as symmetric as possible, because it
Mm-hmm.
makes your what's it called, your analysis like way easier. So and talking about the NASA rover from last year, um, basically it's pretty symmetric. Ideally, it's pretty symmetric, but obviously manufacturing it or the manufacturing process of it, it's not going to lead to it being completely symmetrical. But in CAD, it's pretty symmetrical. So in my case, I would just do an analysis on basically like the joint points where the suspension system connects to module 2, which is the main frame of the rover. And I would do another
Mm-hmm.
relation on where the tire meets the what's it called, the suspension system. I forgot what I named it, because that's basically where the majority of the critical loads are going to be experienced. And then based on that,
Mm-hmm.
you could kind of interpolate like, is this structural good or not, or where can I add more support and stuff. But yeah, like I said, ideally you want to make your designs symmetrical. That way you can just do it on one particular segment, and then you can kind of use whatever you did on your simulation. If your simulation is accurate, you can apply it on the rest since it should be symmetrical.
That's cool. I have one more question. Um, so like would you be able to, or would ANSYS be able to like show you like I don't know if it's relevant, but like I guess like a shear stress diagram, stuff like that, like from solids, Does it produce that, or is that?
Yes, it does.
Oh,
Um, I just haven't been able to find to actually like
is it,
like apply it in person, but it does have it. I've seen
oh,
videos
that's cool.
that have it, but like I just gotta find that feature, I guess.
Okay. All right. Yeah, that's all I had for questions.
Anything else you guys?
So like if you were like doing a curved surface or like the ball we were gonna do at the beginning, the only thing you would really change is just uh, like the meshing. You wouldn't change. Well, how would you fix? Can you fix on like a point instead of a face? Or
So I guess the way I would do it, like I've never done it before, but just based on my brief experience with ANSYS, is I would probably like in the 3D model, I would probably model like a base on the like like a base on the sphere. Let's say it's like a bolt, like a what's it called? Let's say it's a bowling ball. I would just model like a base, and I would model some sort of like 4-point constraints on it so that it doesn't theoretically doesn't move, and then I would apply the force on top. I don't know if I don't know if I'm making sense.
yeah, I get what you're
Uh,
saying.
so I wouldn't in the geometry portion I wouldn't just import the bowling ball. I would import like the floor and then some sort of like constraints that way theoretically it doesn't like roll or something to kind of just constrain it, to have more ways to constrain it.
I see.
Were you guys able to get ANSYS pretty easily, or did it take a while to give you like the download link or something?
I was
Uh,
actually gonna ask Alex, which particular one are we supposed to get? I have not gotten it yet.
You're supposed to get just ANSYS, and then I have release 2019. I think on that link that I sent you. Let me see. Were you guys able to check out that link I sent you?
I was able to get there, but it's like ANSYS Discovery, ANSYS Student. I think there's like 4 options: Discovery Lite, Live, Discovery Aim, and just ANSYS Student.
Yeah, so it would be ANSYS Student, and then you just click on download ANSYS Student release 2020.
Okay, and just step by step follow it.
Yeah.
All right, thanks, Alex.
so the problem I had was like it downloaded a bunch of programs, but they weren't in the same location. So when I would try opening something, I didn't know it was like ANSYS Workbench because there was a bunch of other ones. Uh, but yeah, right now I'm not working on that because I'm on my laptop.
Yeah, man, that's welcome to ANSYS, bro. It's so disorganized. Um, but yeah, it's Workbench. The thing about ANSYS is like the company itself is like always purchases like a bunch of smaller software and then it just incorporates it into their big umbrella. So that's why like let's see, like when you download it, you're gonna get this folder, right? And then it has a bunch of like extra stuff that I'm probably never gonna use, but it just comes with it. That's why it's like a 20 gig like download or something. And then for what I use it, all I need is Workbench. So I'll just go to Workbench.
In order to try and save memory, we could delete the other files, right? And just use Workbench.
Yeah, you can. I think it gives you an option to click out on some stuff. Or like the classic ANSYS is just Workbench for mechanical engineers. And then, as I explained it earlier, for people that weren't here, it has a bunch of modules. ANSYS Workbench itself has a bunch of modules. The computational fluid dynamics module is called Fluent, which I'm going to do a workshop on it sometime in the upcoming month. That's for fluid dynamics and stuff, simulation. Anything static related or anything like statics or mechanical solids, you're going to do under static structural, which is what we did today. And then there's a bunch of other modules that I've actually never worked with, but seem pretty legit, like an internal combustion engine, simulation, hydrodynamics, electrical stuff. But yeah, I'll use static structural and fluid for competition fluid dynamics. Have any of you guys used ANSYS before this workshop, I guess?
No, man. I haven't.
It's a really good tool, good tool to be familiar with, since basically anybody in industry uses ANSYS for the most part. I think now the upcoming competition to ANSYS is called Abacus, which is basically SolidWorks version, or the people that make SolidWorks, which is I think the Sol Systems or something like that. It's their version of ANSYS. It's pretty good. I've used it like 2 or 3 times. It's a lot less cluttered than ANSYS, but from what I've heard from people that have been using this for years, Abacus is good for like if you're simulating like non-linear kind of stuff, like elastic or materials. That's one thing that ANSYS is not really good at whenever you have like some sort of
Like polymers.
yeah, stuff like that. Yeah.
And so that abacus, it's like under Dassault systems.
Yeah, and Abacus itself, like it's like almost 180 degrees from SolidWorks. SolidWorks is like really close down. If you only have 2019, you can only share with people with 2019, stuff like that. But Abacus, like for being the same company, it's a lot more like liberal.
Yeah, but it doesn't come with SolidWorks. It's like its own separate thing, right?
Yeah, but they offer a
Student version.
free student version, which I might do a workshop in the future for this because it's actually also pretty good.
Yeah, man.
Yeah, this is Abacus. I think they offer like a free download for student edition. Like I said, that's more for like it's got a better solver for polymers and stuff like that. It gives you better results.
I see, man. Have you ever used I noticed that ANSYS has like a damage feature. Have you ever used that?
No man, ANSYS has everything, but I've only used
Like deformation and stress.
and I'm kind of barely learning Fluent.
I see.
But yeah, any of the other modules I haven't used.
Yeah, man.
Any other quick questions? If not, then that probably concludes the workshop.
Yeah, man.
All right, I'll upload this to the YouTube channel and then share the link on the chat.